Light Reflection and Refraction Part 4 Class 10 NCRT. Today we are discussing about the topics that is refraction by spherical lenses, image formation by lenses using ray diagram, lens formula and magnification, and at last power of a lens. Our first topic is refraction by spherical lenses. Actually, we have two types of spherical lenses are there, convex and concave. In the convex lens, there are two spherical surfaces are there that is bulging outwards. From this figure, we can see that the middle portion is thicker compared to the edges. That is called convex lenses. When the light rays are coming parallel to these convex lenses, it will converge into a specific point. So these lenses are also called converging lenses. The second type of spherical lenses are concave lenses, where the spherical surface is curved inwards. That means it is thicker at the edges than the middle. From this figure, we can see that the light is coming parallel to this concave lenses, and the lens diverges the light. So this lens is also called diverging lenses. If we consider a convex lens or a concave lens, it has two spherical surfaces. From this figure, we can see that the concave lens and convex lens have inward and outward spherical surfaces are there. These are the part of a sphere, these spherical surfaces. Always we know that the spheres have the center point. The center is called a center of curvature. Here two spheres are there, that's why two center of curvature will be there. It is represented in C1 and C2. The imaginary straight line passing through these two center of curvature is called as principal axis. The center point of this lens is called as optical center. It is represented by using O. And the diameter of the circular outline of a spherical lens is called as aperture of that lens. And the lens has two principal focus. They are represented by f1 and f2 in this figure. The distance of the principal focus from the optical center of a lens is called as its a focal length. Now let us consider a ray of light coming from the object. If it is parallel to the principal focus, then after refraction from the convex lens, it will pass through the principal focus. In case of the concave lens, then it will appear to diverge from the principal focus. When a ray of light passing through the principal focus, in case of convex lens, it will emerge parallel to the principal axis after refraction. And in case of concave lens also, when a ray of light appearing to meet at the principal focus, after refraction, it will go parallel to the principal axis. When a ray of light passing through the optical center of a lens, either it is convex or concave lens, it will emerge without any deviation. Our next topic is image formation by lenses using ray diagram. When the object is at infinity, the image will be formed at principal focus, and it will be inverted, real, and a diminished one. This type of lenses are used in telescope. When the object is placed beyond 2f, then the image formed will be inverted, real, and a diminished one, and the image will be formed in between f and 2f, that is opposite side of the lens. And this criteria is used in cameras and eyes. When the object is placed at 2f, then the image formed is inverted, real, and the same size as that of the object, and it will be formed at exactly 2f, that is opposite side of the lens. And this criteria is used in the photocopy of making same sized copies. When the object is placed in between f and 2f, then the image formed will be inverted, real, and a magnified one, and it is formed beyond 2f, the opposite side of the lens. And this type of lenses are used in projectors and photograph enlargers. When the object is placed at principal focus, then the image formed will be upright, virtual, and magnified, and it is formed at infinity. This type of arrangement is used to produce parallel beam of light. For example, it's a spotlight. When the object is placed in between principal focus and optical center, then the image formed will be upright, virtual, and a magnified one. And the image will be formed behind the object, and it is in the same side of the lens. And we used this type of categories in the magnifying glasses. In case of concave lenses, when the object is at infinity, then the position of the image will be formed at principal focus, And the nature of the image is it is virtual, erect, and a highly diminished one. When the object is placed in between infinity and optical center, the image will be virtual, erect, and a diminished one, and it is formed in between principal focus and optical center. Next one is lens formula. It is a relationship between object distance, image distance, and focal length. By using this all, we can express the lens formula as 1 by f is equal to 1 by v minus 1 by u. Next one is magnification. Magnification of a lens means how much the image is resized with the, compared to the object size. That is called a magnification. We can calculate this magnification by using this formula. That is the height of the image divided by height of the object. One more formula is there. That is image distance divided by object distance. Our last topic is power of a lens. It is the amount of light a lens can converge or diverge. It is expressed in terms of power. Power is the reciprocal of its focal length, that is P is equal to 1 by F. For a convex lens, it is positive, and for a concave lens, it will be negative.